Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to a new topic. Today's topic is about Enterprise Resource Planning System, ARB. After we talk in the previous two chapters, we talk about database in details, talking about database modeling and also talk about the database and administration and so on. So now we will talk about the ARB system, which means how we demonstrate the integrated database or relational database into reality because it's based on software, as we said. So as you see here, we in the first slide we have just to show that the finance account, all of these functions, manufacturing, human resource, supply management, project management, customer relation management, all of this will contribute to the ARB system. What we are going to learn this in this topic, first we will understand the general functionality and key element of ARB systems. We will understand the various aspects of ARB configurations, including servers, database, and the use of bolt-on software. We are going to understand and get to know the purpose of data warehousing, which is the basis of the ARB, as a strategic tool for recognize the issues related to the design, maintenance, and operation of data warehouse. We will also try to go to discuss the risk associated with ARB implementation. Also, we will try to discuss the consideration related to the ARB implementation. And lastly, we will try to discuss the internal control and audit implication associated with ARB's system. The good start to understand the advantages of ARB system is to look back to the traditional model, which employs the closed database architect, which is similar in concept to the basic flat file model. If you still recall the flat file model, which is based on separate database for each system, it carry many issues and problems, including redundancy, lack of communication, and incompatibility between systems. If you see here in this figure, we see that here we have customer order. Let's say in terms of if the sales order, we have manufacturing and distribution system. We have the function of procurement system. So three procurement, three process or three systems. Each one of them they have a separate database. That's the main concept or the concept of traditional information. So it's information will be redundant in each database, and because they are not connected. So let's look to the ARB systems then. ARB system is a multiple model application software packages that integrate key processes of the organizations so that a single computer system can serve needs for each area. Okay, so this diagram illustrating the that in the business under the ARB systems, we have what we call one database warehouse. This is the database warehouse. We will explain it in detail in a minute. And then we have system. We have the ARB system. This operational system which the operate the process of database, connect the operational database for each system, which we talked just now about customers production and vendors inventory. All of these systems will be connected and connected through the ARB systems to first upload to the database warehouse, and then to also generate a report based on the database. Okay, so we will have detailed slog and profound discussion in a short while. What is the advantages of using ARB system? First, integrated enterprise-wide, allowing for better flow of the information. That is one of the main advantage of ARB system. The flow of information is improved due to the integrated enterprise-wide model or concept, as it is stored in a centralized database and can be accessed by various departments, which also improve the customer services. Okay, again, data captured once, meaning that there is no chance of having what we call redundance. So let's say if we record in the sales department, we record the information about customers. uh, so the accounting users, or the accountant, when they use the accounting software, there is no need to key in again the customer information again. This is quite same to the what we call to the database or relational database advantages. And then it improves the access of control, because by having the ARB system, it improve the access of control through the security settings, because you have one database, and then you control the access of the users of that database. Okay, then standardization of the procedures and reports. So because we instead of having different standards for each software, so we have the same the same report, or the quite standardized. It's not necessary to be same, but it will serve its purpose. So what is the disadvantages of the ARB system? So first, it's costly, complex, significant amount of time to implement, users resistance, learning new things of is sometimes hard for employees, for sure. So it is costly because the vendors of ARB system is requesting a lot of money. Complex because it connect and integrate all of the all of the software management software within the organization, and even sometime within the business partners, mean including the suppliers, and including the customers as well. Then significant amount of time in implementation, because especially for big and middle class size of the company, then it require more time. And for sure, because using the by implementing ARB system, the existing users will face difficulties, and they will have what we call learning resistance curve. They will resist to learn, because it bring them to a new norm and so on. But I believe this is not a problem anymore, due to what we face in COVID-19 and the lockdown environment last year, and this coming year. This bring us to be more flexible, more easy to change, due to what we are facing those years. And then I believe this one will if company plan to implement ARB system, it shouldn't be a problem with the existing stuff. So what is the ARB system contains of? It's content of two main element, or two main components. First is the online transaction processing applications, OLTP, and we have online analytical processing, OLAB. So we will explain both in details. So the online transaction processing OLTP applications is the core applications to handle the operational support day-to-day activities, meaning that it's handle the operations within the other software connected, so including sales and distribution, business and production, planning, shop floor control, and logistics, meaning that all of the transactions, all of the applications transactions like accounting software, human resource software, marketing software, other software like manufacturing, production, and so on, all of these softwares are handled and processed by the online transaction processing applications, OLTP. And then the second one, the second side of ARB system is online analytical processing, OLAB, which include decision support, modeling, information retrieval, ad hoc reporting analysis, and what if analysis. In other words, if you see this, it means that the OLAB is mainly for analysis, analyzing the database, and also to generate reports and support the decisions. So a data warehouse is a database constructed for quick searching, retrieval, ad hoc inquiries, and easy of use. So we will discuss how these two element of the ARB systems are working with each other in a short. Let's look now to the ARB system configuration. First, most ARB systems based on client-servers model, in which users' computer accesses ARB programs or systems and data via a host computer server. This is what we call a two basic architectures. And then we have typical two tiers model. The server handles both applications and database duties, used for local area network lane applications for which server demand is restricted to a small number of users. We will discuss what is the networking and so on in chapter 12, inshallah. So then we have that database and application functions are separated in the three tiers model, typical of large ARB systems that use wide area network WANs. So we have two configurations of ARB system, main configuration systems. We have two tiers model, which is for small number of users. We also have ARB systems for large numbers using three tiers model. So this figure is explaining the two tiers client server. You see here we have the first tier and the second tier. In the first tier we have a few users. We have presenting the layers of users, and then we have in the second layer. The second layer here is we have the modem or the computer or the server that handle the applications and database layer. So those are this application or this model is, we call it the second layer, since it handle the database and application by the same server, but it handle the less number of or small number of users. Here we see the three example of three tiers client server, and here we can see that we have three levels. In the first layer we have the customers or the users, sorry, the users including customers and any users of the software or the ARB system, and then we have in the second layer or tier, we have the applications and the application database and the server, and then we have the third layers, which is the database and database layer. So it shows that we have three layers. One is users, then we have applications, and then we have database users. We normally use this model when we have big companies or big number of users. For example, now Lazada or other other companies or which handle more users to use the software or the system, like banks and so on. Okay, so they use the ARB system based on the three tiers client server configuration. Let's have a profound look into the online transaction processing and the online analytical processing, OLAP. OLTP, as we said, online transaction application or process, is support mission critical task through the simple inquiry of operational database. So it's clear it's about missions and tasks. So it's based on the transactions, whereby OLAP, which is it brings the most advantages of the database or the what we call the ARB system, support the management critical tasks through the analytical investigation of complex data associated captures in data warehouse. So we have this kind of thorough analytical procedures and investigation can be in sort of consolidation, consolidation or drill down or slicing and dicing. So what is consolidation? Consolidation is the aggregation or roll up the data. By rolling up the data and trying to integrate and find connection between the data. And then we have drill down, disaggregation the data to reveal underlying details. Okay, then we have slicing and dicing, enables users to examine data from different viewpoints to uncover trends and patterns. This illustrates the tools of the OLAP, the online analytical applications or procedures. So you see here pivot, drill down, roll up, dicing, slicing. So it means that when we have many data, how to extract data and bring more meaningful, drawing down, getting more details about things, rolling up, getting information about one thing but from different dimension. So that's why we have different color, just to illustrate that. Whereby dicing, it's illustrating or taking out some information from from the big data or from a huge amount of data. Slicing also same, but using different techniques. Pivot is taking how to say center of something, let's say the customer range, and then based on that we the customer volume or the customer credit record, then we based on that we the data can do data mining based on that. Okay, so that's the main difference between the OLTP and OLAP. OLTP is running or supporting the applications or the operational applications, many transactions, latency sensitives, small payload, and balance read write or heavy write workloads. That is the functions of OLTP, whereby OLAB, it's few transactions through throughput sensitive, large payloads, heavy read workload, and including full table scans, meaning that it's if you see less I mean less transactions, but it is to support the management decision and so on. This diagram illustrates the difference and the connectivity between the LOTB and LOAB. LOTB database is representing the business process, whereby the LOAB database is represent business data warehouse, and for the business process, or OLTB is for the operations database, whereby LOAB database is not based on transaction. It's not, we don't record transactions, we record information, or we can see that the OLTB is the database for the database that operate daily base, and then it come here to as information to store in data warehouse. And then the functions here is data transaction record, whereby here the functions in the OLAB is data mining, data analysis, and big data. This figure also explains how OLTB and OLAB operate and relate to each other. So under the ERP system, the OLTB, online transaction process, having operational database, separate database for each applications or software. We have accounting software, for example, we have sales software, we have human resource software, and so on. So then those softwares will transfer as a master data transaction into the business data warehouse under the OLAB, online analytical processing, and then this will produce useful information and useful reports to support the decision making and improve the operation as well. So it's connected again, the output of the data, the analytical processing of the data warehouse is also connected to the OLTB. Another figure to explain the OLTB and OLAB client server. See, we have three tiers. We have first tier, second tier, and third tier. In the first tier, we have the users presentation layer, and where they are connected to the server of OLTB server application and OLAB server application. And normally when they are connected or they are acquiring some information from the OLTB server, then it will drive again it will, in the second layer tiers is the database application OLTB, and it will be connected to the operational database, to the specific operational database. And let's say this user is the accountant and require information about the accounts and so on, so it will go to the OLTB surface to update the software, and then it will saved in the operational database, the accounting the operational database. Again, same things will goes for the sales man and so on. When they update the software and so on, the system, then it will update the operational database. Okay, but for the reporting and so on, it will goes through the OLAB server, which connected in the second tier under the application layers, and then it's connected to the data warehouse to get the information, and also to do some analytical information based on the software, ERP software, to generate uh, a useful and visualizing the data in a very meaningful and summarized form. Let's talk now about database and plot-on software. Plot-on software is a software where it facilitate and make it easy to integrate different applications into the ARB system or different systems. As we know, under the database configuration, ARB systems is composed of thousands of database tables, specific database table, and process selected by setting switches in the system. So how to do that is based on the plot-on software. Plot-on software, as I said just now, is a software that can be easily attached to a client project or software or system. For example, a website, they have website, then it's easily to connect to their software or their ARB systems or database and so on. Um, it is less risky, this software, the plot-on software, to be provided or endorsed by the ARB vendor. So the plot-on software and ARB, sure, it is less risky to when it comes from the same vendor. ARB systems and supply chain management is an example of the two systems. ARB systems and supply chain management systems are now on converging path, where it links the vendors, carrier, logistic companies, and the information system providers. Now let's talk about database warehousing. Since we talked just now about OLEB, it's based on the database warehousing, not in the operational database, which is for the OLTP. So OLAB, the online analytic applications, is based on the database warehousing. So what is database warehousing? So we need to understand what is it. It is a multi-dimensional database, often using hundreds of gigabytes or even terabytes of disk storage. So it's because it's connected, it's collecting data from different operational database in the companies into one integrated database. So having said that, so what is the single database what we call it? So when we organized for a single department or functions, often we call that data is data mart, which only has tens of gigabytes of data storage, serving the purpose of that department or that function. So what are the functions of data warehousing? Is extracting, converting, and standardizing operational data from the ARB system and loading those data into the data warehouse. So let's look into the 5 stages of data warehousing process, starting by modeling data for data warehouse, and then extracting data from operational database, and then cleaning extracted data, and then transforming data into the warehouse models, lastly loading this data into data warehouse database. So we will explain each one in details. So data modeling, for the data warehouse, we need to create what we call the schema of the database of the warehouse, and then based on this schema we will extract then we extract or collect the database from the operational database. And then when we collect it, then we will have what we call this or denormalized database. We need to normalize this data by cleaning and cleansing this data. So by deleting the what we call the redundancy and so on, we will discuss that in a short while. And then after we clean the data, then we do transforming this data into the warehouse model, which we build based on the schema built in the data modeling data. And then after that, we load this data into the data warehouse database to be ready for the OLTP for database analytics or data analytics, or what we call the what we call it also the data mining, for data mining. To simplify those 5 stages of processing the data warehouse, starting by the extracting the data from the operations database, and then transforming this database after and cleaning it, cleaning the data and transform this data into the database warehouse modeling, and then lastly loading this data into the database. So if we load, then we will generate reports and send to KPIs systems for the data analytics and so on. Okay, so in explaining that stage one, the modeling data for the data warehouse. Why we need to do that? Because of the vast size of data warehouse, the data is denormalized, and we know that relational theory about database relational and so on does not apply to the data warehouse system. Why? Because it is big data, and it is come from different operational database. So we need to clean it. We need to do the second steps. We cannot just accept it as it is, because it's denormalized, because we sales department, they have their own information about customers. The same information will be also for the for the accounting department and for the inventory department and so on. So we need to create different data based modeling for the data warehouse. Normalizing data tables regarding to selecting events may be consolidated into denormalized tables. Okay, so data warehouse modeling is the process of designing the schemas of the details and summarizing information of the data warehousing. And then second one is extracting data from operational database. The process of collecting data from operational database, flat files, archive, and external data sources. Change data captured can reduce extracting time by only capturing newly modified data. So just the modification or just the update. Okay, then key features of data warehouse is that data are in a non-volatile or stable state, loaded in loaded in only when transactions is completed. So when transaction is completed, then it will be loaded into the data warehouse. Extracting operations data in slices of time provides non snapshots of business activities. So meaning that we have different files based on the operations and so on, but we what we when we extract the data, we extract the data based on the timing. We will explain this how it's operate in one figures after while. So here we have an example of the normalized database in the operational database system level. So you see here how it's connected and so on. So connected with the what we call the primary key and so on. Same, those three tables are connected. Whereby when we come to the data warehouse system, it is denormalized, and we can see here it is represented in one table. So what we need here, we need to clean the data and clean this data, because what we need to understand here, now we are recording a transaction, not transaction, we are recording information. Transaction level, it is based on this. We record the transaction here. Okay, so if we have different transaction, new transaction, it will be recorded here. What will happen here? Here will be only the record of the update, the record of update only. The update, it will be extracting the update of that specific customers, and will be recorded here as new customers, and so it will be redundant. So that's why we need to clean the data. After we extracting the data, now we need to clean or cleansing extracted data. So we should know that the operational data, the extracted operational data are dirty for many reasons, because we extract from different database, operational database, and this data is carrying operations when we gather them into in one table. Okay, so we are in need to filter out and repair the invalid data before we send this data and upload it to the warehouse database. Also, we need to transform data into standardized business terms with standard data value. So let's say we in one database or in one operational database, they use vendor instead of supplier as or source supplier. So we need to standardize these terms to use, let's say we select vendors instead of supplier. So we need to standardize the terms used in the business, in the warehouse. We cannot use different terms for the same function or same transaction. In stage 4, we should transform data into the warehouse models. Data warehouse model has been established or designed in the stage 1. So database transform into a summary views before being uploaded. Unlike the operational views, which are virtual in nature with underlying basis tables data warehouse, the data warehouse views are in a are physical tables. Okay, so OLAB permits users to construct virtual views from details data. Stage 5, where we are ready to load the data or the extracted and transformed data into the data warehouse database. So data warehouse must be created and maintained separately from operational database. It shouldn't be maintained along with and together with the with the operational database. Why? in order to have internal efficiency, integration of legacy systems, and consolidation of global data. Because we cannot bring the operational database and create it and connect it directly with the database warehouse. Uh, Remember, database warehouse is to serve and create a meaningful and support decision process throughout creating analytical analysis and report, giving patterns, giving some indicators to read the future and the market, and also to read how the customers is thinking, and other indicators through that data on hand. So it's not operational database, it is database to wising and supporting the decision making, critical decision making. Okay, that's why we call it, in order to have internal efficiency of integration of legacy system. I believe this figure is very important because it's explained how the data warehouse systems is processed in terms of the how the ERP systems is operating, connecting the operation database and data warehousing process. So under the legacy system, we have some the systems or the applications, the separate applications like order entry systems, purchasing entry, sales entry, accounting entry, and so on. So all of these systems will be connected into the VSAM files. A VSAM is standing for Virtual Storage Access Methods file, uh, which introduced in first by IBM as a software to control the access to the database, and controlling the hierarchical database and networking database. And then it's send the connection to the operational database. So when operational database is when we extract data, when ARB system extract the data from operation database, then the ARB system will clean the data. We should clean the data cleaning thing and process, and then when we clean the data and transform this data, we should have this data, let's say, into a summary. Remember, when we talk about operational data is based on transaction. So let's say, but data warehouse is not based on transactions, it's based on reporting. So you see here current details of sales data, current details of sales data. This is monthly record, this is quarterly record, okay, and this is annual record. For the same update, it's updating not based on transaction. This transaction is based on updated in the operation database, and then when we extract and capture or snap the data, we bring the information into here. This is an example. Let's say maybe it's weekly, maybe it's daily. It's there. So if we have weekly, then we will have 4 here, other 4 update. For example, if we do it weekly, and then if we do daily process or daily transform, then we will have 5 or 7 days operation. Anyhow, it's not a matter, but we need to understand here the process, the difference between data warehouse and the operational database. The operational database is based on transactions, recording the transaction, whereby here it's based on information. based on information extracted data from the data warehouse. When we extract, we need to clean the data. Data extracted data, we need to clean it, and also what we need to transform it into summarized form. Okay, and this summarized maybe monthly, daily, weekly, there, and also annually. So we see here, if it is monthly, then we update the here we update the every month we will update here. Okay, so this one is for the month one, this one is month two, month three, month four, and then if when we have the for the 3 months here, and then we will have the update for the quarter. The data warehouse will run as a quarter update, and then we will have also for the previous quarters. So this one is based on the quarters. Okay, and here we have yearly or annually. So here we have previous years, here previous quarters, previous months. Okay, so this slide is explaining the the relation between data and data warehouse and the OLAP, or online analytical applications, and the output. What is the output of the OLAP? Okay, so data, we have extracted sources, external sources, and operational database sources. So the operational database sources is based on the marketing database or software, based on the accounting software, based on the other on in-house, or the internal software we use. And then also we have external sources like information from suppliers and from the internet, from social media. Now all of that are forming the data warehouse. So what we need to do to do the data warehouse, to update the data warehouse, we need to extract from the operational database, we need to clean, we need to transform, and we need to load and refresh. Okay, so when we have the data here, now it's the data warehouse here, you see, and we need to administrate this data and monitoring this data separately from the operational database. Okay, so data warehouse server, and when we extract the data here, it's data marts. Okay, so and then we have the OLAP servers. We have OLAP servers, and OLAP servers is, we have, let's say we have middle tier, we have more than OLAP servers. If we have only one, then that's it. And then we have front end tools, which is the either data mining, analytics, and query reports, meaning that is the output of the ERP system. Okay, now let's talk about decisions supported by data warehousing, or how it will be different. Okay, so some decisions not fundamentally different from those supported by traditional database, because traditional database will generate some information. Let's say it can generate, let's say, the financial statement, some indicators, and so on. But this also the data warehouse can generate the same thing. It's not much different, but other informations uses such as multidimensional analysis and information visualization are not possible in traditional systems. When you want to create buttons, you need to have connect you to connect, let's say, some information from social media. You connect some information about social about let's say survey you conducted for about customers, and let's say you need to have analysis about information about the customers satisfaction along with other product of the competitors. That is not possible with traditional database. The primary reasons for data warehousing is to optimize business performance. Okay, so drill down capability is a useful data analysis techniques associated with data mining. So drill down meaning we already talk about it in a minute. We say that drill down is it means dig more about more details. So the tools are evolving rapidly to satisfy decision makers needs to understand the business unit's behavior in relation to the key attitudes or the key entities, sorry. The main idea is that when we have data mining and as a part of it data drill down, now with data warehouse, which we said is a data we have huge data come from different source, operational data source, and as well as from also from external source. Those information it's kind of power in the hand of the organizations, and day by day there is a new tools evolving to satisfy the decision makers to understand, to have better understanding of the business and as well as by customers and so on. So data mining is the process of searching large set of data to look out for patterns and trends that cannot be found using simple analysis techniques. So data mining, there are many techniques under data mining. One of it is decision trees, sequential patterns, clustering, prediction, association, classifications, and so on. It's not our topic to focus in data mining, but when we have big data, big set of data, then we will start to talk about data mining. And this topic or data mining is connected to the big data, is connected to also to the artificial intelligence, talking about clustering, regressions, and so on. Those are the neural networking and so on, deep learning and so on, of the machine learning and so on. All of this is based on the data mining. Okay, so this is some examples or applications of data mining. Let's have the examples of banking and investment field. We have, let's say we have here the deduction buttons of fraudulent credit card, and identify the layout customers and predict those likely to change their credit card affiliation. Examine the historical market data to determine the investor stock trading roles, predict credit card spending of key customers groups, identify correlations between different financial indicators. So by having data warehouse, ARP systems will allow the banks or the decision makers here to predict some information about the credit card spending in some groups, let's say female and male. Though the female holder of credit card how much they spend, and maybe we can connect it and get buttons, the timing, connected with the salary they have, with the location they live in, or they with the work they work in, or maybe even the race. We can bring all of this information and do deep analytics to get patterns that can wisen and improving the decision making. Cares, marketing, all of this can be, you can go through and check the what is the applications. Let's talk now about risk associated with ARB implementation. So when company implement ARB system, there is a risk. Remember, when we talk about the disadvantage of ARB, we say that ARB system is costly, complex, and it takes time to implement. Okay, so what is the risk related to the ARB systems? Number one is Big Bang method in implementing. We have this Big Bang method needs we stop the operations and switch in one event, in one single event, to use the ARB system. So method of implementation is the more impetuous and risky option, as organizations switch operations from legacy system or the old system to the ARB in a single event. It's good, it's very promising, but the risk here is high. Why it's high? One is one of the disadvantages of using Big Bang method is related to the numerous failure due to the opposition and distribution, as employees adjust to the change, because as we said, the resistance of changes is changing from employees. So this kind of shocking change may raise failures of the implementation of ARB system. So once the adjustment phase has passed and the new culture emerged, ARB system becomes an effective tool providing competitive advantages. Okay, so that is it's good, yeah. It is risk, but it will bring the competitive advantages when we use ARB systems, when we adjust and embrace this culture. As I bring to you previously, that it is not a matter now, it's not a big problem with the existing stuff, especially during the current time where we have the forced lockdown, the forced transforming 180 degree from office based working to be virtual online based working. So the second type is, or the second method or approach is phased-in approach. It is a popular alternative of Big Bang for the organization whose units do not share the common data and processes. So phase by phase, changing or switching from the legacy operation system into the ARB system. But remember, it's not this one is more applicable to the organization where it has different units. The units or departments are using they are not having common data and process. So independent systems instead installed over time without disruption, and can also be used by firms that are not diversified, meaning that the company that is have same it's having same or common data and process can be, but we need to carry some risk in terms of the time, taking time to transform and reach to optimal ARB system. The opposite to change in the business culture, as we said, this is it's risk, but I believe with the pandemic lockdown culture created by COVID-19, I think it is not a problem nowadays. Another risk associated with ARP implementation is choosing the wrong ARP. What we mean by choosing wrong ARP systems. In the market out there, there are many vendors providing different ARP systems with different features and functions. And we should keep in mind that there is no best ARP product uh, fit all the industries or the different organizations. So we should make sure that this ARP is fitting the organization or the company. So the choosing the wrong ARP is one of the crucial or the very important or very strong risk. Why? Because remember when we talk about what is the disadvantage of ARB system, it's costly, it's complex, it's difficult to implement, it takes time. So imagine you have wrong ARB systems and you try to squeeze and implement it into your company. So you need to have, before choosing the ARB, you need to first understand what is the ARB systems, what is fit to the industry that your company or your organization is in, and then you understand the system scalability issues, addressing the system's ability to grow, and should consider the size, the speed, the workload, and transaction cost. Meaning that when you choose ARB systems, you should understand this system can be scalable, can be extended, can be upgraded in terms of size, speed, workload, and transaction cost. Otherwise, you will, if your company or organization grow up after some time, 4 or 5 years, then you need to change the system as whole, not just upgrading. And this in order for you to select the right ARB systems, you should also consider having the right consultation. So risk, one of the risk of ARB implementation is choosing the wrong consultation from wrong parties. And then we also talk about high cost and cost overruns. So risk comes from underestimating underestimated and unanticipated cost. So if the risk comes from you underestimate how much we should spend for implementing ARB system. So you come to the middle of road, then you say, oh, this is, it's very costly, I should stop. Or when you let's say you get the amount that you pay for the or you plan or you budget the ARB implementation, but you don't plan the anticipated cost along the way of implementation. Let's say training, changes, implementing new stuff, and so on. Commonly experienced problems in training, systems testing, and integration and database conversion. Performance measures should be established and monitored from the day one in implementing ARP. Lastly, the distribution to operation. So ARP systems implementations involves business process re-engineering PPR and major changes in business process should be expected. So we should expect huge huge and significant changes within the organization, because it will change the the concept of database management or administration and so on. So it will bring different concept even in terms of reporting channels to the management and so on. It will be different, it will be very fast, the operation will be different in term of in term of reaction and decisions. So we the training will play role in train the management levels, operational management, and so on. Implications of ERP system for internal control. The first ERP implication into the internal control activities is to the transaction authorization. The controls needed to validate transaction before they are accepted by other models. So meaning that the controls should take place to validate transaction in the software accounting softwares or other softwares or applications. So it should be validated before it's accepted to the ERP systems or other models. ERP systems more depend on programmed controls than human intervention, meaning that it's more IT applications control, more IT controls compare rather than the human or physical controls. With regard the segregation of duties, manual process that requires segregation of duties often eliminated in an ARB environment. So more to be IT segregation of duties. And then organizations must establish new securities, audit, and control tools to ensure duties are properly segregated, including role assignment. Okay, then lastly, supervision. Supervisors need to needs the supervisors sorry so supervisors need technical and operational system understanding, so meaning that they need to have what we call IT training to understand the how to supervise properly with the ARB system. The other issue related to supervisions, it doesn't mean that if the company implement the employee empowered philosophy, so we should eliminate the supervision role. So supervision should still should take place where even the organization implement employee empowered philosophy. Employee empowered philosophy, which is it means that the giving the authority and the independent decision making process to staff or employees. Okay, then with regard accounting records, internal control, so need to ensure the input of the accounting records, because corrupted data may be passed from external source and will corrupt the database, and it may imported the legacy system data may be inaccurate, so it will in bulk or corrupt the legacy system, sorry. And then independent verification, focus needs to be redirected from the individual transaction level to one that views overall performance. So instead of having the verification in the focus in the individual transaction level, to be on the views of overall performance, because remember we are talking about ARB systems which facilitate more the overall performance of the organization. Ongoing verification can only be conducted by a team well versed in ARB technology, meaning that they are expert in ARB system, so they can those team can do the verification of the ongoing verification process. And then we have access control, which is one of the cornerstone of will be will be affected by the implementing the ARB system. The first, access security is critical control issues in ARB environment. Goal is to the goals of ARB is to maintain data confidentiality and integrity and availability. So we need to ensure those three objectives. Security weaknesses can result in errors, corruption, financial statement misrepresentation, and cyber crime. Here we see the traditional access control versus the role-based access control. Actually, we did mention this in details when we talk about the internal control or the IT internal control applications. We did discuss one of the activities control in the level of input control. We discussed the traditional access control and role-based access control. So I'm not going to discuss in details, but what we need to understand that the traditional access control, it gives we create a list of roles, a list of access, what they can access. So that's the list, and then we the ID will be giving to someone or to the users who can access the permission and get the permission assigned to individual to use. So that's the list of information related to the users. So, and we can see that each user is assigned with list of access control list, whereby in the right side of the slide you see the role-based access control. Here we have kind of roles, one, role 2, and role 3, and so on. So then we connect the users to this role. So let's say role 1 is about updating or checking the credit limit. So will be user 1 and user 2 can do it, but user 3 cannot. Or user 3 can do, or he's the only one or she's the only one who can access and do the role 3. Okay, that's the main things. I will not go in details, but because it's easy and it has been explained earlier several times. Okay, so this is a kind of example of role definitions. So that's it's just again giving the ARB role name, which is, let's say in this case, is the account payable processing, and role goal is data entry of customer invoice and check request, where the location is account department. The knowledge skills, knowledge of invoice processing from receipt to payment and relevant finance and procurement and so on. So you can see that this is a kind of role definitions that it created for ARB system. So the responsibilities and task, what they should do is review and verify the barked invoice submitted to the account payable, bark non purchase order invoice check request, entry invoice for goods received into the this company is AB. And then we have security consideration. We have display documents. We have display uh, recurring entry, then vendor line item, what they can display, what they can check, what they can what this stuff can do, and edit the invoice, back the invoice and edit. This is also another display changes, what they can change, and so on. Okay, so this is a kind of example to show how we create the role definition for specific role. Here we will discuss the internal control issues related to ARB roles and contingency planning. It's kind of what is the risk or what is the issue related to the ARB roles and the contingency uh, planning or issue. So we have creating of unnecessary rules, because when we talk about the using the role-based access, so maybe we create unnecessary roles. And then the other issue is the role of less access. So access privileges and permissions should be granted on a need to know base, but users tend to accumulate unneeded permission over time. Managers fail to exercise adequate care in assigning permissions and tend to be better at issuing privileges than removing them. So they keep giving permission of access, permission of privileges of accessing more than removing these privileges from unneeded privileges of access from staff. Policies should require due diligence in assigning permission, and then monitoring rule creation and permission granted activities. So role-based governance systems allow managers to view roles, permission, and individual assignment, identify violation, and verify that changes have been implemented successfully. Lastly, organizations need a contingency plan or plan B to be ready to invoked quickly in the event of a disaster or any abnormal circumstances. Thank you so much. And let me recap the main points. So today we talk about the ARB system, and we say that ARB systems is the integration or the configuration of two main functions. First is the data or online transaction processing or applications, where it process the transaction or the day to it support the day-to-day operations and so on, and it's based on different applications and so on, accounting applications and database and other sales inventory and so on. All of this applications is based on online transaction, is connected to online transaction applications, and is connected to the OLAB. OLAB is online analytical processing, and online analytical processing is supporting the critical management decision making and providing information and reporting. But OLAB cannot take place unless we have what we call data warehousing. And data warehousing, we have 5 stages to transform or to get the data from the operational database or the applications database and transfer it to the data warehouse. And remember the difference between data warehouse and the difference between data warehouse and the operation database is data is separate data for each applications. It handle the updating and the transaction of the application, let's say accounting applications and so on, whereby the data warehouse is extracting the data from the applications data or the operational data, and bring this data, clean the first extract and then cleaning this data, and then transform this data according to the data warehouse modeling, and then lastly load this new data into the data warehouse, the physical data warehouse, and then after that it is ready to be used by OLAB. Then from that OLAB we can extract and visualize visual report, and have what we call data mining, searching for deep analysis that we explain also about the type of data mining and so on. We did explain the the risk associated with implementing ARB systems, cost in terms of cost, wrong vendors, wrong consultation, wrong choice of ARB systems and so on. So I think that's the main idea or the main point. I'd like to thank you again, and see you during the class. Thank you. Assalamu alaikum.